Okay, I've been, I just was so busy getting my screen share up that I don't have a chance to show you the National Geographic um, magazine that came in November 1993. This is 27 years ago. It's been lurking on my desk, but it has this title, Water, the Power, Promise, and Turmoil of North America's Fresh Water was the subtitle. And so I've included some of that in my talk, and you can see my emphasis on Niagara Falls because it's my favorite way to harness energy without having to dam up a river and cause a lot of turmoil. It's a very natural way of harvesting the potential energy from nature of elevated water. And the four of the five Great Lakes are above the Niagara Escarpment. And so there's a lot of water falling over these falls. I'll show you in the next slide just how much, or give you a better idea. This is a view from the Skylon Tower on the Canadian side. And you can see Goat Island in the center of your image, which is American territory. Just past that, there's an imaginary line you can draw down the middle of the Niagara River, and all that you see on the right here is Canadian. The Horseshoe Falls, I think, are roughly half Canadian or so, and the other half American, and then there's the American Falls over here. I used to live way over here, just on where the Lake Erie forms the entrance or the source of the Niagara River. And I went to work over in Buffalo at Roswell Park Memorial Institute, a cancer center, and each day, but we would get visitors from Europe and elsewhere, and whenever they came, we had to show them. It's a fairly short drive up to Niagara Falls, so I got to know the area quite well. And this view is quite dramatic. It's a wide angle view, but it shows the development along the Canadian side of excellent viewing opportunities. There are some from Goat Island, but I don't think it shows quite as well as over here. And this picture here was taken from the Canadian side. In the distance here, you can see the entry areas. It's difficult to use the pointer because I advance the slide, but you can see the, if I go very slowly, I might not advance the slide. You can see the intakes here from the Canadian side for water. I mention that because it says here 20% of global fresh water passes over or under Niagara Falls. About half of that 20%, probably 10%, goes underneath Niagara Falls and gets divided in half, about 5% on the American side for providing energy for a lot of New York, including some for New York City. And the other half of that, about 5%, would go into the Canadian side and provide a lot of electricity for Ontario. When I was a boy, I grew up in London, Ontario, and we called it Ontario Hydro, and because it was all hydroelectric power coming from Niagara Falls. So I grew up being accustomed to hydro energy. In 1979, they built a barrage here and shut down the American Falls for several months, thinking that there was too much crumbling and too much erosion in that area. And so they had it dry, and I remember visiting it and seeing it all dry. They were doing some tests, and they found that it was actually a little more secure than they thought, and they didn't do very much. It's a pretty solid dolomite and magnesium calcium carbonate layer that the Niagara Escarpment is made from. So they left it pretty much alone. The next slide shows a little bit better how I come up with the ideas about fresh water. These are some interesting facts from that issue of National Geographic, and you may see it elsewhere. 97% of the Earth's water is seawater, but only 2% of our total water, or 2% of that, another 2%, making up a total of 99, is locked in ice caps and glaciers, and only 1% of the Earth's water is left to circulate. And circulate, by that I mean to condense, to evaporate and then condense as our rainwater. Um, this third point, 250 cubic miles of water, doesn't mean that it's the same as the 1% that circulates, but it's a certain fraction of that. We're not given that information, but a certain fraction of that is said to evaporate every day from the land and seas and then condense as rain. So I think these are interesting points. And over here, this photograph I took from the National Geographic. If all the Earth's water fit in a gallon jug, and they've got a pretty little picture of North America and South America on there, the available fresh water would equal to just over a tablespoon. So it's a significant thought. Therefore, our problems with water have to do with distribution, not the amount of it. We have plenty of it, although we could make more. We've talked about desalination plants, and those, if powered by nuclear energy, which is very condensed and has been offered in the past by Oak Ridge to both Los Angeles and Israel, but turned down both times, might be used to provide more fresh water at some point. But at the moment, that hasn't been done to any significant amount. And so we're left with constant amounts of seawater and fresh water. This is a slide that I showed to you at the top part of it a couple of years ago when we were talking about energy. And this was an image that they had in the upper right here of some turbines that would, these were basically water wheels, and there were 238 of them proposed of 500 horsepower each. And that was the original plan put forward for the New York side of Niagara. And along came this fellow, Edward Dean Adams, and he recognized this as a backward plan with old technologies. He realized that you could really harvest the energy much more effectively if you made penstocks. These are large vertical tubes 100 feet tall that would, or more, that would allow the water to gain momentum through its mass and velocity and much more efficiently generate electricity. So he consulted with Henry Morton, Edison, and some Swiss experts back in 1889, and he was largely responsible for that. I should have perhaps kept his photograph. It was a little hard to do, but he was on the front cover of Time magazine about 100 years ago. And Adam Beck in Ontario did comparable things on the Canadian side, and he was knighted by, I think, probably King Edward VII at that time. So that's just a little bit of background about Niagara Falls. Getting back to another question, and that I haven't really thought about that very much, but where did our water originate? There are a number of theories, but most people seem to accept the fact that most of it came from these objects in two bands, one around the sun. Here's a proto-Earth halfway between the sun and a proto-Jupiter under formation, and this is the asteroid belt. And these, from these asteroids, probably was a secondary contribution, carbonaceous chondrites and meteorites. Then there's some other meteorites thought to come from this, and they're called enstatite chondrites. They're not carbonaceous like those in the asteroid belt. They're thought to be, don't have so many carbonates. They have more of the raw metals and some sulfides. And they were thought not to have much water in them more recently. They've found some down in the lower right here that landed these meteorites near Toulouse, France. And they realized that there's a lot of water in those rocks too. And somebody has calculated that there's enough water in them to have provided for, in this proto meteorite material, to have provided for 3 times as much oceanic water as we have on our planet today. So that seems to be the favorite theory at the moment for where our water came from. The third possibility is comets, although the massive comets and their passage by the sun and the Earth and giving us water is probably a distant third. Anyway, it's an interesting idea to think about where our water came from, because the other inner planets, Mercury, Venus, and Mars, besides the Earth, are not don't seem to have a great deal of water. Certainly not as much as the Earth does. Some people think there's some buried under under the crust of Mars, but certainly not anything like the amount that we have on this planet. So we're very fortunate to live where we do. Water also makes up a good part of us. We're 60% water. Our brains are about 73%. Our bones are about 30%. So if you take the whole human body, it comes out about 60%. So it's a good, important molecule to be aware of where it came from and where it's distributed. These are a couple of new theories that have been coming out in Science magazine. You can see the reference over to the right. But there's this biotic pump theory that suggests forests not only make rain, but also wind. And when water vapor then over a coastal forest condenses, it lowers the air pressure. And that allows it to move further inland. And so that was an idea for what they call wet winds. Not universally accepted, but an interesting idea. I find this idea, flying rivers, perhaps a little more theoretical. They claim that the Amazon provides so much moisture in the air that it provides 70% of the rain for southeastern South America. And they've also talked about this one across Europe and Asia. 80% of China's rain comes from the west, thanks to a trans-Siberian flying river. They have some other conjectural rain parades on this map. I'm not sure how real they are, but it's an interesting idea and may help us to understand in future the problems that we're having with maldistribution. We call it maldistribution, but it seems mal meaning something we're not accustomed to, because there does seem to be a change as the planet is warming in the intensity of our hurricanes, which are giving a lot of moisture to the southern part of the United States this year. And also we have not enough rain in the West Coast, particularly California. And this is a bit of a thought change from water, but I couldn't resist putting in because it's so relevant to today's current events. And so the Department of Forestry and Fire Protection in California came up with this pictogram displaying the causes of forest fires. There was some talk about it last night, of course, on 60 Minutes. There seems to be an awful lot of human activity here that are responsible. Debris burning, electrical power, of course, is from the wires that are blown down in high winds, extremely high winds. And those are hot wires, which then can lead to sparks and so on. Vehicle use, responsible for a remarkable amount of it. Equipment use, arson, lightning, only a small relatively amount, campfires, playing with fires, smoking, and of course, almost 40% of it is undetermined or miscellaneous. But not mentioned anywhere here is the drying of the forest floor by the extreme high temperatures. That is just going to point out that my son lives in Carson City here, and he and I have been having some interesting conversations about the active areas of fires and what they're dealing with coming over Lake Tahoe, the pollution that they're getting in their city. And you can see the active areas still persisting. That made me think about the whole issue of where he works, because I thought that my son was mostly working methane plants, but he tells me that he spends a lot of time looking at the vibration of the turbines in hydroelectric plants, and they're distributed all in these areas as well. So I learned from him a good bit about those different hydroelectric plants that I was talking about earlier. Okay, coming now to California. This is from the 27-year-old magazine, and I've done my best to update it in places, but a lot of this still applies. So here we have the state of California, and we've taken this orange area and displayed it in this fashion to get a better look at the variations in mean annual precipitation. 60 or more inches where it's dark blue, 40 to 60, and then 20 to 40 where it's mauve here, or sort of a pale purple, going down to white where it's very little. And then some aquifers are outlined here, Owens Valley, Antelope Valley, etc., Santa Clara, and the Central Valley Aquifer. An interesting demonstration of Palm Springs here through the year and their precipitation in inches versus Eureka, which is up here in Northern California, and Palm Springs way down there at that other end. And so they began in the 1930s to provide support for transporting a great deal of the natural runoff from Northern California to the south. And they built these giant aqueducts. They call these penstocks, just as they do in hydroelectric plants, for pumping the water. It comes over the Tehachapi Mountains here, which otherwise block the water from getting down into Southern California. And they point out again that on the average, about 24 inches of rain and snow a year come down in California, but 3/4 of the rain and snow falls in the sparsely populated north. And so by having these aqueducts and canals, they have been able to provide sufficient water for most of the California crops that we find at our supermarkets today. And this shows in better detail the Central Valley Project with these solid lines, some other federally supported water projects in other areas. The Colorado River Aqueduct here, bringing water over from Lake Havasu, and so on. So it's been quite an achievement. This is a final update. What I showed you was 27-year-old data. Now it's fairly well updated, and the size of these blue bars at the bottom represent the water delivered in 2005, not totally up to date, but an improvement over 1993. And the length, of course, in miles, I suppose. Anyway, the size of these arrows displays fairly well that 70% of California's water comes from the north, and 80% of it is consumed much further south, thanks to California's good plumbing. Now, there are a couple of areas up in this area, up here in Shasta Lake, that were thought to be a good supplier of water. And they had quite a drought for 6 years between 87 and 93. Some of you may recall it when we lived here in Madison. I remember having to water my lawns in 1988. Haven't done it since that I can recall, but they were very dry out there. And the Shasta Lake dropped to 1/3 of its normal level. And so they had a hard time doing much water management from here, but gradually the lake did recover. But it left an attitude in Californians. And so I'm going to talk a little bit about water ethics in Santa Barbara. This was highlighted in the article. I thought this is a pretty dramatic photograph. On the left, you see a house that uses half as much water as the lawn on the right by selecting plants that are attractive and contributes to a good looking lawn. I'm not sure if that lawn is on the edge of a beach or a street, but in any case, it shows pretty dramatically the difference. Another place in Santa Barbara where they have to spray their lawns with biodegradable dye called Oasis Green. Still others sprayed their houseplants inside with toothpaste rinse water. So they've been getting pretty creative in California for quite a long time. They also traded in their toilets. These are the largest indoor consumers of water in our country, and they were traded in for just $100, so you could get a brand new toilet. If you were a handyman, install it yourself or get a plumber to come and do it for you. The new models use only little less than 1.3 gallons of flush as opposed to 1.6 or 1.7 in the old toilets. Doesn't sound like a big improvement, but it did save millions of gallons of water for the state. So coming back to this map, now we see it in a different light where the green here is, if I can find my pointer there, shows the irrigated areas and the pink, the built-up areas. So in San Francisco, for example, most of the water is consumed in the city and not very much in the surrounding countryside, whereas in the Sacramento River region or the San Joaquin River region or Tulare Lake, these are mostly irrigation uses and not so much in the locations. So this also came from the article. It was a pretty spectacular shot from the air of water-intensive crop, that is rice. It was criticized by many as a monsoon crop in the desert, but farmers here have won praise by flooding their fields after the harvest and turning them into water wetlands for migrating waterfowl. But that may not be, if water gets more and more difficult to provide by irrigation, that may have to change. We'll see. I had hoped to put in a slide showing the variations. Here it is, good, it just came up at the right time. We see the variations here in precipitation between 1950 and 2015. And you can see there are a lot of below average years, and there are a few above average. And but if you look at since the turn of the century, there's a lot less precipitation. But what's even more dramatic is the temperature, and this, of course, contributes to the dry forests. You didn't see very much above average temperatures before the turn of the century, but it's been quite dramatic since. And there's no sign that this is going to change anytime soon. I was a little surprised last night that people were as optimistic as they were. I can understand some precipitation changes in cycles, but I think these temperatures are reflect a clear trend in relation to climate change, even though people don't want to admit it. And I think we need to get serious about not only conserving water use, but about the elevated temperatures and how to deal with this with proper energy selection, shutting down coal plants, I think. And for that matter, methane plants, because of their contribution to greenhouse gas, we need to think more seriously about that. Moving now to the Northwest, I've shown slides like this before when we've talked about hydroelectric power, but I'll review this with you because this is, these little red dots are Corps of Engineer dams all along the Columbia River. And you can see the outline here of Washington State, Oregon State, and Idaho. And it shows some interesting use of dams along the Columbia River. I worked out in a little town called Anacortes in 1956, studying the sockeye salmon that were destined to come up to the Fraser River. And it was an international organization. The goal was to try and preserve the salmon in Canada, saying that the Columbia River was pretty much finished because of these dams for fisheries. But they have managed since then, 1956, to try and maintain reasonable salmon distributions with good fish ladders. And I think it's improved somewhat and probably still competitive with the Fraser. Anyway, I wanted to just show you this dam as an example. and give you a few numbers. So this is the Bonneville Dam, the very last one after which the Power Administration is named. I happened to be driving by there on my way to visit another son in Portland, Oregon, and I took this picture just as we were driving along the interstate. And you can see that this dam is one of 31 that produced 22,000 megawatts of electric power. And the average is about 280 megawatts each. And if you can look up at those windmills up above, each one of those represents about 1 megawatt on the average. Some of the newer ones, a little bigger, go up to 1.2 or even 2, but the vast majority average out in the neighborhood of 1. So you can imagine that dam there as, on the average, this one is bigger than on the average. But if you think of each one on the previous map here is 280 wind turbines, each one of those yellow or red dots. So that's a lot of energy. And what's better than windmills is that it's 24/7. And those dams were built about 70 years ago and will probably be there for a good while longer. We do not have to fill up landfills with the used turbine blades that only last 25 years or so. So there's a lot to be said for understanding, much as we're enthusiastic, and I personally like the looks of windmills in the sky. It reminds me of airplane propellers, and I find it charming. Not everybody agrees with me. I certainly don't want to take them down, but I think that we need to be careful about damming dams and damming nuclear power, which are provide good baseline support. Hydroelectric dams, by the way, have a capacity factor, and we've talked about that before, are quite a bit lower than nuclear. Nuclear has a capacity factor, that is, they generate up to that level of the total capacity, installed capacity, about 95% over the years that follow, whereas hydroelectric dams generally run around 35 to 40%. I think the reason for that is probably that they may have to shut them down partly for cleaning. They may also have to vary it because more than nuclear, you can follow the load with hydroelectric power, and that may be just simply part of incorporating into the grid. So now we come to another part of the United States. The largest water reservoirs in the country are Lakes Powell and Mead. Powell is up above Glen Canyon here, near the junction of our border of Utah and Arizona. And the other large one is above the Hoover Dam here at Lake Mead. Lake Mead was built in the early 30s. Glen Canyon Dam was built about 30 years later, toward the end of the dam building, 4 decades of dam building in the West. Nobody seems to mind Lake Mead. Perhaps it's a little closer to where areas that can be irrigated, but people are questioning the value of the Glen Canyon Dam. And we'll talk about that a little bit as we go through these water reservoirs. Here's Lake Mead. Water here is used for irrigation, but it had to be curtailed because you have these penstocks that require 100 feet or so of water over them. And if the water level gets too low, then those don't function, and they have to be have to hold back on irrigation in order to keep the turbines running. Moving to a slightly different aspect, and that is the dryness of conditions in the Colorado River Basin. You can see quite readily here at a point in time, this was from last June the 23rd, different levels of extreme drought varying quite a bit around the Four Corners here and up in Utah. And you can see it with time, how they've had extreme drought back in the early parts of the century, but picking up again in the last few years. There's another thing that we don't talk about very much, and that is the Native American tribes that have significant rights to their lands. These tribes are mentioned here, Navajo, Ute, and many others here. And they want a seat at the table as new treaties are being negotiated. So these are all things to consider in terms of the future use of the Colorado River. I bring to your attention this little branch here. The Grand Canyon is about in here, and it's a branch just downstream from the dam, and this is called the Little Colorado River. And I'm going to show you in a couple of slides another look at that. But here is the controversy with the Glen Canyon Dam. People say, well, it's a good constant source of renewable energy, and that's true. And it's a good defense against severe drought. It's going to help for irrigation. Those who are opposed to it say that it's a large loss of evaporative water. Well, water doesn't get lost. It just evaporates and rains plentifully and helps some farming downwind, wherever that might be. So I have a problem with that opposition. They do have a little bit of a point on it altering the ecology of downstream Colorado River. And this is a little critter that bothers people. This is a very ugly looking little chub. At least I think he's ugly looking, but he's really evolved and adapted there with a huge musculature on his back to deal with the very rapid waters that existed more readily before the Glen Canyon Dam was put in. Every time there'd be a flush of water down the Colorado River, these little fellows would have to swim vigorously to cope. And so they've evolved, and then we have a thing called the Endangered Species Act. And since the dam is put in, these things don't seem to be thriving quite so well. And so there's been some talk, and I can see how the environmentalists and the energy people might get into a conflict over an ugly little chub. I used to study chubs in Ontario when I was a pre-med student, and I got to know them and like them. And this is certainly the ugliest chub I've ever seen, but he's adapted to where he's living, and that's just fine. This is another way of looking at it. We've got reservoirs, but we also have aquifers. This is an example in Haskell County, Kansas. And I think it's a fascinating thing. An aquifer is an underground layer of gravel, sand, or permeable rock that holds groundwater, and it can be extracted by wells. And it took thousands of years for this moisture to accumulate, in these wells. You have unsaturated gravel here in the upper layer, more saturated further down, and then sandstone containing usable water, but then further down saline. So you have to be careful how much, and we're apparently using more than is being replenished. And we're going to have to think about this more seriously, probably within this century, possibly even within decades. Coming now to the Mississippi watershed. It's the second largest watershed in North America. And notice the word is North America. There's a much bigger, well, not much, but quite a bit bigger watershed up in Canada called the Hudson Bay watershed, which drains the northern part of several large provinces. But it's still, for this country, it's quite an impressive watershed, draining 40% of the lower 48 states. And they say the Mississippi River is the second longest river, and of course, the slightly longer one is its branch, the Missouri, that goes way up here to the Rocky Mountains. Look at all these little lines. These are the various dams and locks used along the Mississippi River. They do generate, some of them, a bit of electricity, but not an awful lot. They're mainly used, of course, for navigation up and down the river. But it's interesting to see where they're located here to improve navigation as the land goes up. Don't think there's some major dams, and I'm going to relate to this on the Platte River. The next slide will show some major dams, one here, one here, and one here. And those dams, I presume they're used both for irrigation and for, since they're called major dams, I haven't studied them, but I guess they generate some energy as well. But the story came out that Nebraskan dams have controlled high water levels so well that gravel bars on which sandhill cranes can safely rest have been smothered by the growth of new brush. Now, I've been there twice, and I didn't take that particular picture, but I could have taken one very much like it. There are 500,000 sandhill cranes gather there in the spring, usually in mid-March, on their way north. And it's quite impressive to be there in the morning as they rise off to go and feed on gleanings in the farm fields before the corn has been planted. and gleanings from the previous autumn. And in the evening, when they come back in to roost for the night, they are safer there from bobcats. Bobcats sure love cranes. So from an edible point of view, so I was a little dubious, but I asked Rich Baufuss, the CEO, recently when I was visiting with him, how true this was. And he said it really has been a problem. They've had to go in and clear out the brush in order to make sure that they have good areas to rest and that the coyotes don't have the cover and bobcats that they might otherwise have if the brush got too high. So apparently it's a real concern. Then this one was taken from the magazine. Mississippi, they use these poetic terms, the sovereign of the North American waterways. This giant river appears to be immune to the ills of pollution. And in spite of 29 locks and many dams and levees, floods do sweep away our illusions of our control sometimes. This is a pretty shocking mountain of trouble. A 60-foot high pile of gypsum covers a square mile at a chemical plant near Baton Rouge. It's a byproduct of fertilizer, contains a lot of phosphoric and sulfuric acids, and they erode and wash into a growing chemical burden on the river. So it does get polluted like so many of our rivers. The Tennessee Valley Authority has, we talked about that before in talking about hydroelectricity. It's interesting how the Tennessee River starts up in this area here in Virginia and works its way past Oak Ridge and Knoxville, comes down into Alabama, comes along west, and then rather than go across to Memphis, it decides to take a turn and go through Tennessee again on a northerly course up to Paducah and winds up in the Ohio River and then goes down the Mississippi. The little squares that you see are these really unfortunate coal plants. When I talked about coal, I might have mentioned to you that this coal plant here near Oak Ridge, actually, it might have been this one here, but anyway, one of them has had a huge sludge pond and it broke. Fortunately, after my mother moved out of the area, she used to live on one of the lakes here, and she moved away as she got elderly, moved up to Madison and stayed at Oakwood for a while. She likes the word oak, I guess, but her house and many other houses along the shoreline were totally washed away by vast amounts of coal sludge, and it contaminated the waterways badly. So I do think we need to get rid of these squares, and the hydroelectric plants here, the triangles, and some nuclear plants are the circles. So I think there's every reason to get rid of the coal for many reasons. People complain about nuclear waste, but compared to coal waste, it's a drop in the bucket. Now, before we finish with Tennessee Valley Authority, I thought this was quite a fascinating look back and a look into the future for that authority. Back in the fiscal year 2007, there was an awful lot of coal burnt. 58% of the electricity was from burning coal. And what a nice reduction in just 13 years to 15%. I'd like to see it zero, but they sure achieved a lot in 13 years. I'm impressed. They raised their nuclear as well as their gas and hydro. They brought in a bit of wind and solar. This EE stands for efficiency of use, and they're getting 1% now. They think as they look ahead, it doesn't seem to be, people are not that efficient. I'm not sure if that means households or the companies that make it, but they don't seem to expect a lot of energy saving there. They expect to, in the next 10 years, to increase their carbon-free energy, mostly with wind and solar. So that's an interesting look back and a look forward, where today we're in the middle circle there. 56% of their energy is carbon-free. Boy, we sure can't say that for Wisconsin. It's too bad. We're about, I'd say we're about 20% carbon-free in Wisconsin. 80% of it is from gas and coal. And we really have a long way to go to catch up with the TVA. We're coming to Canada now. I found this kind of interesting. I have paddled a canoe and flown an amphibious plane up on the Ontario side to James Bay, but I've never been over this area except by high plane in jets flying to Europe. And when you do cross this border from Ontario into Quebec, you see a dramatic difference in logging. The forests are very, very rich, and you can actually see this line as you fly over it in a transatlantic jet. They typically go over this part of Canada to make a shorter line to Paris or London. And so you really see that line quite dramatically. And the reason is that logging is easier to do now is that this was all taiga forest and very primitive forest. I'll show you a picture of it later. But there's this fellow, I don't know if you've ever heard of him, by the name of Bourassa, who was the premier of Quebec back in the 60s and 70s. And he referred to all this water up here as a waste. I don't think he was at all concerned about the Cree First Nations and their concern for their primitive way of life. But they viewed Bourassa as we now view people cutting down the Amazon rainforest. They really did not like him. He also had a conflict with Pierre Trudeau at the time. Trudeau was more of a federalist, and he wanted to take the Cree concerns into account. Nunavut was being developed on the other side of Hudson Bay as a region under their control. And so there was a very difference in political views at the time. But anyway, Bourassa came up with this idea and became very powerful and managed to get this thing called the La Grande Complex. And this is the La Grande River here. And he managed to dam up vast amounts of it. And it actually worked pretty well. They got a vast amount, I think it's something like 118, I'm not remembering it very well, but a vast amount of energy, probably as much as we're getting out of Lake Mead and those big reservoirs to the southwest. It was fairly successful, but the Cree certainly didn't like it. It inundated some of their precious forests, their way of life, their graveyards, and so on. And so they mounted a lawsuit because Bourassa wanted to develop this as well, and also this area down here. And that went through various courts. They argued that Charles II had given this land to the Hudson Bay Company in 1670, and that therefore the Indians didn't have any rights to stand on. But the Federalists like Pierre Trudeau and others fought back and managed to come with a negotiation that satisfied the Cree more or less. Instead of developing all this into huge dams, they diverted a river here called the Rupert River, and they diverted it up into what's called the East Main. And I'm going to try if I can use my arrow here without changing the slide. You can see the Rupert River, and they just diverted not all of it, but about 70% of it up into this lake, which drains down to the East Main. And you can see that if you hunt carefully here. I have to move my pointer with great care. I change the slides. But you can see a little dam there. And that's a proposed dam, but it worked. And so now the water goes down there. So they basically increased the amount of water flowing through the Grand Complex, and they canceled this one entirely, much to the pleasure of the Cree, who felt that this was pretty far north into Hudson Bay, and they did not want that to be changed. Still, it was a very large project, and they now provide 40% of Canada's hydropower, and they export a lot of energy to New England, provides 10% of their power. So they've accomplished a lot. They have no nuclear plants, and I suppose they just don't want to be bothered because there's all this water that they can capture. And I think there are plus and minuses. This is a typical Cree woman who's hanging caribou meat to dry. But in 1973, I mentioned this injunction was filed, and it was overturned by the another court based upon Hudson Bay thing, and 22 million were granted to the Cree and Inuit, and they seem to be more or less happy for a little while anyway with that plan. This is an idea of some photographs that are taken of these waters. They're really beautiful. If you're a canoeist or a photographer and wanting to enjoy nature, it didn't hold much, it was just considered a waste by Barassa. But people have been raising a lot of questions about dams, and I have to ask, what is the problem? Other than the very mild ones that people had to say about the Glen Canyon Dam. And they point out that natural flushing functions of a river are blocked, and that's a shame to do. They feel that deep water and reservoirs can be so low in oxygen that aquatic life downstream is affected. So that can be a significant problem. I think the second one is even worse. Toxins accumulate at depth and contaminate fish. I didn't realize that there's mercury in some of these leaves and logs and wood that accumulate above dams. And that material can become methylated and get into fish. And they found that the levels of methylated mercury in pike and whitefish are 3 to 7 times higher than normal. They have not made measurements in the indigenous peoples to look at their IQ, but there is a concern that it may have, this happened fairly soon in time after the dams were built along the Grand Complex. And so there is concern that there could be mercury release and could be contributing to poisoning in a way, or seriously contaminating the food value of the fish in the neighborhood. And of course, the ancient artifacts were flooded forever, but at least the Great Whale River, which is shown here, was canceled and not taken advantage of. So what's not so wrong with dams? I took these pictures from my plane recently. It's fairly close to the dam that we've visited twice now at Prairie du Sac. You can see the dam here, and you can see from this crane that they're doing some work on the dam. This is the part that we visited here. We went in and saw that they had 8 turbines of 4 megawatts each. So they generate 32 megawatts. It's equivalent to about 32 wind turbines, but it's 24/7. And it also helps to control flooding and aids in some water diversion when people need to have the water higher or lower for various reasons. The recreational activities are considerable. A lot of people enjoy boating above the dam all the way up to Merrimack and beyond, I think almost as far as that unfortunate coal plant up at Portage. But they need care, and this dam is 105 years old. I took this picture as a close-up showing they've been putting in with this piling steel rods that reinforce the wooden poles that have been put in 100 years ago. Those wooden pilings last a long time underwater, but when the water level goes down for some reason and the tops of the pilings are exposed to oxygen, they do deteriorate. And so in order to keep that dam maybe for another 100 years, I hope, maybe less, I don't know, but they're seriously trying to maintain that dam as well as possible by investing some money and putting in steel rods. They've been working on it all summer, and I think they've probably just about wrapped up, but we'll see how long it takes. I've been on their website, but they don't project how long they'll be working on it. I threw this slide in. It's a slide from Alex Canara, somebody most of you know. He pointed out that David Seary, a Sierra Club member back in 1966, was in favor of nuclear power in contrast to their views today. And in fact, it led to a splitting of the Sierra Club some time ago. But he and Ansel Adams both said that nuclear energy is the only practical alternative. And the Sierra Club's motto was atoms, not dams. I think that whereas with Niagara, there's not a problem with hydro, but it does have some significant negatives, hydropower, when you start building dams. And so the statement was this view was generally made that Niagara and nuclear are preferable to dams. Now, in this section of the magazine, they talked about pollution, and this photograph was taken from a mine where the water was going into a pond where the tailings and the refuse of the mine were held for a long period of time, and possibly would have to be drained in some fashion eventually after some of the worst things settled out. But they didn't really say very much about it in the article. Those words, climax molybdenum, were there. So I went and Googled the climax mine, and this is what I came up with. The company has been sold that was originally mining there to another company called Climax Molybdenum. And I found that 85% of the world's molybdenum comes from this mine. I said the world's molybdenum. It's a very important element used in steel alloys to make the steel more corrosion resistant and stronger, used extensively in the aircraft industry and in manufacture of engines, internal combustion engines in particular, but in all kinds of high strength steel. So it's a very important source of molybdenum, and sometimes you hear the term chrome moly steel, meaning that it's an alloy of chromium, molybdenum, and iron to make a very superior quality steel. So, and to the best of my knowledge, they've done as well. Any mine pollutes, but they've done as well as most other mines in dealing with their pollution. So it made a striking image in the National Geographic, but I think that they're doing a reasonably good job at trying to minimize the pollution. This was another picture from that magazine. They said risky fishing in the Fen Holloway River. In the warning here, it says fish from this river are contaminated with dangerous levels of organochlorides and dioxin that can cause cancer, birth defects, and miscarriages. So I did a little work on this one, and also this was from a pulp and paper plant, and this has been sold, and it's now been taken over by Foley Cellulose. And they make cellulose for all kinds of things, for wrappings around our vegetables in grocery stores, for diapers, for senior depends type of pads, and all kinds of things. They've invested $300 million cleaning up their effluent, and they have $100 million more planned. So they seem to be proud of it. This is 27 years later. They've changed the exit for the plant to be much closer to the Gulf of Mexico, where the river empties. So that seems to be a somewhat of an improvement. The other one that they mentioned in the magazine was the Nashua River. I had faintly heard of the Nashua River. It's in Massachusetts. It just kind of dips up and catches the southern part of New Hampshire and then drops back into Massachusetts as it joins a larger river and empties into the Atlantic. But upstream, as you see on the left, there's a lot of pulp and paper plants as well as some sewage. It looks pretty awful. On the right, they've got a nicer, brighter, sunny day and a nice, clean black river, but it's cleaned up of its dirt. I think the story of how this happened was quite interesting. They just mentioned in the article briefly that this gal by the name of Marion Stoddard came along. She married a physicist out in New Mexico, I believe, and moved with him when he came to the Massachusetts area, settled in a town that was just next to this river. And she was shocked to find it near her home. She had 3 children, and she didn't want to be so close to one of the 10 most polluted rivers in the USA. And she got really serious. She met with state governor and paper mill executives and began a campaign with every way she could imagine and try. And she succeeded so well that she was recognized by the United Nations, by the National Geographic magazine, and others. She's now 94 and still going strong. And this is a picture of her enjoying her river with others as she pedals down the Nashua River. So I thought that was a nice upbeat ending to the talk. I am going to just mention this before we leave. This is a complicated graph, but it shows on the abscissa along the bottom increasing high water stress. That means not enough water in most conditions, or the water will go down suddenly because of a lack of frozen water in the Himalayan mountains. On the ordinate here is water productivity. And you can see that Japan has used its water pretty well in hydroelectric plants to the degree that it can, in the United States reasonably well. These other countries are kind of down in this region where they don't have a lot of stress and a lot of productivity. The size of the country is estimated by the size of the area here. And they've sort of shaded in a dusky color India and Pakistan. The reason that I show you this slide is that I've focused all my time. I haven't even talked about Mexico. It's down here on this graph. I've restricted my remarks mostly United States and Canada, with which I'm most familiar. But I could, if you wish, and I'm really interested in would like and appreciate feedback from you about whether you want me to go into this next spring. This is a thing called Asia's Vital Rivers. And there are a whole bunch of them from, if I flip my pointer around, I'll go backwards, but there's everything from the Mekong River to the Yangtze River to the, it's a little Irrawaddy River to the Ganges River and so on. They're all here and they're important because the water that is normally held in the mountains is in glaciers is melting, and so you're getting a rushing of water in the spring and not the continuation of water through the summer. And that's going to be a problem for Asia. We could talk about that. It's a bit of a more depressing story than I think what I've given you about North America. So I have some other ideas. We're learning about fusion more and more in the last few days. Lots of exciting things we could talk about fusion as compared with fission, or a number of other subjects, but I'm dependent upon you for working through the fall and winter on next spring's slides. So I'm hoping that you'll let me know and give me some feedback. And so now I will close the PowerPoint and entertain your questions. If I can get to them, there we are. I see we've got 20 attendees now. And let me go to the question and answers. I see 4 there already. Somebody says my voice is too soft, so I'll have to speak up a little more loudly. I'll hope that helps. I'm sorry about that. Julie asks, what is the snow line? I don't know. It's a good question. I can't answer that. I was wondering myself, and I haven't found a solution. Tom Eggert writes, I've heard statistics regarding how many of the world's rivers no longer reach their mouths. Do you have a sense of which rivers these include? My answer is, well, the Colorado is the most famous that we all know about. I don't have a list, but I have a sense that the Colorado is probably the worst of those. I'm not aware of others in Asia. I certainly don't know of any others in the Americas that are anything like Colorado. Colorado is so unique because its waters have been piped across to supply our food production in California so dramatically that when you think of 70% of the water comes either from Northern California or from the Colorado River, it's pretty dramatic. So I think that's a classic. Let's see if there's some other questions here. I don't see any others. It's 11 o'clock, but we don't have any deadlines. Anybody want to raise any other questions? I can comment. Oh, Tom is responding again. The settings on your end prevent my video from going on. Let me see. I don't know what my settings are, so I'm not sure how to respond to that. Mert Corwin says, do the fresh waters absorb CO2? Yes, they do. CO2 readily enters water at its interface whether it's oceanic or fresh. But the volume, the surface area compared to the ocean is 1% versus 97%. So when you take that into account, it's something that might not be so dramatic as in the oceans. The oceans, of course, are much deeper than our lakes and freshwater, but so much of the freshwater is moving, and probably other things contribute to some acidification of lakes and rivers more than the direct CO2. So to answer that in general, I would say, yes, freshwater has absorbed CO2, but it's probably not a major issue in acidification of freshwater. Alan questions. He wants to ask me to comment on rivers that are silting below dams. He says he lives down in Brodhead, Wisconsin, and he says that Decatur Lake, if that's the correct pronunciation, is very shallow now behind the dam and rapidly filling with islands. And that is a problem. Some areas, I mentioned when I talked about Quebec, that the Great Whale River was, they decided to cancel that, and also an area below La Grande. Both of these areas were very silty, and they had the wisdom not to build dams there because they knew that they would rapidly clog up. Fortunately, even though the Wisconsin River has a lot of tannin in it and some suspended sediment, it doesn't seem to be a problem when you think that that dam has been there for 100 years. I've not heard of problems of mercury release, although it would be interesting to look into that. But so far as silt, that's interesting to me that Decatur Lake has it silting, and they need to deal with it, or it's going to be a problem for the dam maintenance. That's about it for the questions. It's 11:05. I want to announce that we have canceled the field trip because Tony and I felt that it was too difficult to park there without using carpooling, which of course is difficult to do during our COVID time. So we canceled the field trip, but replaced it with your positive voting with a talk about the Antarctic. And so I will be giving that next week. It's mostly pictorial from National Geographic, but some science from a recent issue of Science. And that seems to be coming into the news. It was mentioned last night in the news hour again about the importance of the western half of Antarctica. And I'll talk at quite some length about the differences between Western and Eastern Antarctica next week. So let's meet at this time and we can go into that. After that, we'll have some guest speakers. I'm hoping that you can hear me a little bit better. I've tuned up my volume, but I don't know if that is helping or not. Tom says, thank you, Richard. I appreciate your appreciation, Tom. So it's good to have your feedback. I'm highly dependent on your feedback for ideas for next spring. Thank you. If you do write to me, I will put down a list of the things that you're in favor of, and then I can send out specific links if I don't talk about that subject that might attract you. For example, a month from today, it's a Thursday, November the 5th, there's going to be a meeting about new nuclear energy in Maryland, and Alex Canara and others will be speaking there. I have that link. It's a little tricky for me to use large full-scale emails anymore because my computer has been misbehaving, but it's quite easy for me to just type in the names of those of you who express an interest in something like that. So if you are interested in the webinar on, I think it's at 9:30 in the morning on November the 5th, a Thursday, about Maryland's use of nuclear energy in the future. And Alex Canara is one of probably several speakers. send me an email and I will add your name to a list and then send that link around so that you can join in. We have 14 attendees still. And I'm happy to entertain any other questions or comments, share them with you. It's a cool morning, but it's sunny, so I hope we can all get out and enjoy the sun today. And it's going to turn warmer this week, so we can look forward to getting back outdoors. And I have the Antarctica talk just about all prepared, so that won't take away much of my time to enjoy the outdoors. Be sure and wear a mask when you're outdoors. I hear the Fox Valley is going a little crazy, and Green Bay, they don't seem to believe in masks up there, I guess. And so, I hope the students here in Madison behave too, so that we can get down the COVID to reasonable numbers. I had a friend from work write to me recently that they have been doing some studies when they do COVID testing, and they look at the number of times they have to enhance or double the multiplication of the RNA when they do those COVID sampling. And they don't normally put the numbers in, they just say positive or negative. But they're thinking about putting in the number of times that the sample has to be amplified or doubled by enzymatic amplification. And I think that would be a good thing, because I'm still convinced that the dose of virus that is passed along is important to the severity of the disease that eventually develops. It certainly happens in other RNA viruses that I've worked with. The more you infect an experimental animal, the more rapidly the disease and the more serious the disease is. And I see no reason why it shouldn't also apply to the coronavirus family. So I would welcome that addition, so that we find out a number, and the smaller the number, the better it would be. The worse it would be, because it doesn't need to be amplified so many times. The higher the number, the better it would be, because it means that the amount of viral RNA that you had to be amplified many times before it showed up as positive. So that would be nice to know as we go through this pandemic and try to know not only whether we're positive or negative, but how much. Also, it seems to me that the White House has been a bit negligent in thinking that they can prevent the disease by testing often. Any test that you do is going to be 7 to 14 days old in terms of how much virus was able to multiply during the incubation period. So it's not going to necessarily say what's happening at that moment. So clearly there large parts of the White House administration is now getting positive because they haven't been wearing masks, which are clearly the best way of preventing spread. Anyway, that's a bit off topic, but it's part of the news, and I'll share that with you. Not having any more questions, I think we can end the session. So I look forward to seeing you next Monday, and do write in with any suggestions or about future topics, or whether you're interested or not in getting the link to the November 5 Maryland Energy webinar. Thanks and for attending, and we'll see you next week. Bye-bye, everyone.